today's problem from sequence of real number, and the problem is using Cauchy's general principle of convergence, examine the convergence of the sequence fn, where fn is given by 1 plus 1 by 1 factorial plus 1 by 2 factorial to 1 by n factorial. This is a 15 marks question from UPSC 2024 optional mathematics 2. Okay, and this is also from exercise of real analysis SK Mapa. We first know what is Cauchy's general principle of convergence. General principle of convergence says that if fn be a sequence which is convergent if and only, this is a strong theorem because this is if and only theorem, that is the necessary and sufficient condition of convergence. For every pre-assigned epsilon greater than 0, there exists k, this is a natural number such that fm minus fn less than epsilon for all n greater than equal to k. This is the condition of Cauchy's general principle. If this condition is satisfied, then the sequence fn is convergent. Okay, and if this sequence is convergent, then this condition must be satisfied because this is if and only. And this condition can also be written in the form mod f of n plus p minus fn less than epsilon for all n greater equal to k, and p this is equal to 1 to 3 to n, that is p belongs to n. Okay, simply we get from this relation by putting m equal to n plus p. This is not very complicated. Now to use this principle on this sequence, we first calculate or we first let m belongs to a natural number and m greater than n. Right? Let m greater than n. And now mod of fm minus fn. Clearly we see that this difference is given by 1 plus 1 by 1 factorial plus 1 by 2 factorial to 1 by m factorial for the first sequence fm minus this is the second portion, this is 1 plus 1 by 1 factorial plus 2 1 by n factorial. Okay, this is for the second term. Now if we open the bracket, both the bracket, then cancel out the term from 1 to 1 by n factorial, and the remaining terms are, this is given by 1 by n plus 1 factorial plus 1 by n plus 2 factorial to 1 by m factorial. This is the remaining term. So we get fm minus fn is this. Okay. Now we use here an important property which is given by, if we write m factorial, this is given by 1, 2 to 3 to m, right? And then this is equal to 2 into 3 into 2 m. If we delete here one term, this is the first term of the factorial. Now if we put 2 into 2 into 2, that is we put 2 in place of 3, 2 in place of 4 and 2 in place of m. So this is obviously greater than. Okay, because all the term other than 2 is less than this. And from here this is given by 2 to the power m minus 1, because here m minus 1 term. So this relation can also be written as 1 by m factorial less than 1 by 2 to the power m minus 1 factorial. This is very important relation for this solution. Now putting all the value of this, we get this is less than 1 by 2 to the power n, because here n plus 1 factorial. Then 1 by 2 to the power n plus 1, and in the same way 1 by 2 to the power m minus 1. Okay, and we delete here the modulus because all the terms in the right side are positive, right? Now taking common 1 by 2 to the power n and getting the result as 1 plus half plus to 1 by 2 to the power m minus n minus 1. Okay, and now this is nothing but geometric progression. Okay, with common ratio r, this is half. So we write the sum of this term is given by 1 by 2 to the power n into 1 minus half to the power m minus n by, this is 1 minus half, because there are m minus n term. This is 1 by 1 is written as 1 by 2 to the power 0. So this is start from 0, 1 to m minus n minus 1. Okay, so there are m minus n term. Now we get the result as 1 by 2 to the power n into, this is from here, this is 2. Okay, this is 2 because 1 minus half, this is half, into 1 minus half to the power m minus n, right? And if we delete this term, then the right side is more greater than this because we delete the subtraction. So this can be written as 1 by 2 to the power n minus 1, because 2 to the power n minus 1 into 1. Okay, we delete this term from subtraction. Okay, and we get the result as this. Here we finally write the result. This is fm minus fn. This is less than 1 by 2 to the power n minus 1. Okay, we get this result. Now to further calculate, it is clear that this is less than epsilon if 1 by 2 to the power n minus 1 less than epsilon volt. Clear? We have to require this is less than epsilon. So this less than epsilon hold only if 1 by 2 to the power n minus 1 less than epsilon hold, right? And this is given by 2 to the power n minus 1 greater than 1 by epsilon volt. Okay, if, and we write if n minus 1 into log 2 greater than log of 1 by epsilon volt, right? And this gives, this is n minus 1 greater than log 1 by epsilon by log 2 volt, and this relation hold if n greater than log 1 by epsilon by log 2 plus 1 volt. Okay, and so from this relation we take the natural number k by using the logic. This is box of log 1 by epsilon by log 2 plus 1, and we may be taken this is plus 1. Okay, then we write that mod of fm minus fn, this is less than epsilon. Since this is less than epsilon, we take less than epsilon for all m greater than n. Okay, for all m greater than n, since we take here at the first step m greater than n, and this is also greater equal to k. Okay, because n must be greater equal to k. We prove this result. Okay, so from this relation we say that fn satisfy what is general principle of convergence, right? So the given sequence must be convergent sequence. Very, very interesting and important problem of sequence of real number. Thank you for watching.